Electricity is nothing to joke about.
We have built many inverter circuits to date. Today, I will build a nice inverter circuit. You might say, like that, brother, there are already inverter circuits on the channel. Why did we feel the need to do this? Since every inverter has a different component and transformer structure, I came across a different transformer like this. You ask me questions about these types of transformers from time to time during live streams or via email. That, brother, I have a 4-legged transformer. How can I make an inverter circuit with this? Our work is easier with standard transformer. There are already 2 primary inputs. Since there are usually 3 secondary outputs, these are the most ideal transformer types for inverter circuit. For example, there is a transformer like this. It has many secondary outputs on it. As you can see, there are many terminals on the primary side as well. So I will continue to make special inverter circuits for such special transformers. Now we will see which terminals to use on this transformer. There are already 2 primary input terminals. We set our multimeter to short circuit mode. As you can see here, there are 2 secondary outputs. How will we connect these secondary outputs? We will join the 2 middle terminals on the secondary side. We will make connections from the circuit we build to the remaining side terminals, and our circuit will become operational. I have 2 pieces of 450 microfarad, 450 volt capacitors. We will connect these in parallel to the primary output. In this case, our circuit will work more stably. We will get approximately 180 to 200 volts of electricity from the output of this circuit. In this case, we will light 5 to 50 watt bulbs brightly, just like in the city power grid. We will use an aluminum block in the circuit. I will talk about the components we will use. Then we will quickly assemble it. The main hero of our circuit is a 6 ampere transformer. I explained it just now. 470 microfarad, 450 volt capacitor. We will use a socket, a 20 turn coil. It doesn't matter if it has many turns. 2 pieces of 44 and 2 pieces of 210 resistors. 2 pieces of 1N4007 diodes. We also have 6 watt diodes that we will use at the output. Now that we have seen the materials, let's assemble them quickly, perform our test, and conclude our video. I was going to mention something in this video. It happened to me, friends. I burned 2 MOSFETs. I had to take the circuit apart and rebuild it. When you make a project like this, absolutely do not supply electricity while the socket is empty.
Always and absolutely keep the load, that is the bulb, connected.
When you supply voltage to the circuit without the bulb connected, unfortunately it blows the MOSFETs. I will use a 14 watt light bulb on the inverter. You can use bulbs up to 50 watts. In this circuit, to light an incandescent bulb, we need to use a transformer around 100 watts, so we can power a 100 watt bulb up. When I apply voltage to these capacitors, we absolutely must not touch them. We need to discharge them somehow, meaning you need to short circuit them like this to discharge them. Otherwise, they will give you a very septic shock, friends. God protect us from it. In these types of dual MOSFET circuits, if you are mounting the MOSFET on a block, you must ensure insulation. When we measure in continuity mode, there should be no connection between a MOSFET and the heatsink. When testing between the heatsink block and the middle pins of our MOSFETs, there should definitely be no short circuit. After providing this information, let's now perform our test and wrap up our video. I will provide the circuit's voltage with a 12 volt battery. We are supplying the 12 volts for our circuit from this coil here. We will also provide our negative voltage to the bridge made to the 3rd pins of the MOSFETs. It turned out to be a very successful circuit. I hope it doesn't burn out the MOSFETs. The temperature of the MOSFETs isn't bad. Gives off a very nice light. Let's turn off some of the lights in the room. Let's take a look at the MOSFETs. The MOSFETs are 42. Let's look at the other one too. The other one is around 20 to 30. So these temperatures are normal for such an inverter, quite normal. This one is heating up more than the other. Especially, we never ever touch the primary side of the transformer in the area where the capacitors are. If you want to use this circuit in daily life, you need to insulate the primary side of the transformer and the capacitor area very well. I'm saying you could get a serious electric shock and I'm ending my video.